Welcome to GateX AML. We'll start with a new chapter or continuity of functions. Very small and important topic. So let's begin. So first we'll understand what we mean by continuity at a point. A function f of x is continuous at a point A. Okay, we are defining a point A if and only it satisfies all of these three conditions. F of A is defined. That means when I put A value in that function, we'll get a definite value, not undefined values. Then limit x approaches say f of x exists. That means LHL, left hand limit and right hand limit are equal, and the limit exists equal to L. And this limit value is equal to f of A. That is L is equal to f of A. If all these three together hold, then only we call it as the function is continuous at that point A. So it's a point continuity. If any condition fails, f is discontinuous at A. So what are these 3 points? The function that at A is said to be continuous if and only if f of A is defined and the limit at A, as x approaches A, the limit exists, and then that limit value is equal to f of A value. So how to check? What is the procedure? First, we verify that f of A exists. So let us say given a function f of x equal to x plus 1. So we are checking if at x equal to 2, this is continuous or not, this line is continuous or not. So first verify that f of A exists. So f of A is 2 here. So it means what? X equal to A is 2. At A I am checking whether the line or the curve is continuous or not. So f of 2 is equal to 3. So it is defined. The first one. Second, compute limit x approaches A, that is x approaches 2, x plus 1 exists. So 2, it exists, both exist, right? So like left hand limit also exists and right hand limit exists, and they are equal to the value L, 3. And then f of 2 should be equal to limit x approaches to x plus 1. So that is equal to 3. Both are equal to 3. Hence, this function is continuous at x equal to 2. That is the meaning. Let us take some examples and then test. Let us say they are given f of x equal to x square minus 1 divided by x minus 1. They are asking you to check whether this curve is continuous at x equal to 1. So x equal to 1, I will get f of 1 equal to 0 by 0. So this is undefined. So the first point that f of A should exist fails. So we say this function f of x is discontinuous at x equal to 1. It may be continuous at any other point, but we are testing for only one point, that is at this point whether it's continuous or discontinuous. Okay, that is the example. So it is discontinuous at x equal to 1. Similarly, they are given a stepwise function. So equal to x square when x is not equal to 2, and it is equal to 5 when x is equal to 2. So let us see. You have to check whether it is continuous at x equal to 2. So when first condition f of 2 should exist, f of 2 is equal to 5, already they are given. Second, limit x approaches A, f of x, okay, you have to find. So limit of x approaches to, okay, so when x approaches 2, so we'll say x square, because at exactly equal to 2, it is 5. But when I say approaches, it can be x can be less than A or x can be more greater than A, that is left hand limit and right hand limit. So that means I have to consider not equal to case. So this will come to be 4. So both LHL and RHL exist and it is equal to 4. Now the third condition is both should be equal. So if question 1 should be equal to 2, I got 5 is not equal to 4. So therefore, it is also discontinuous. It is discontinuous x equal to 2. This is called as removable discontinuity. We will see shortly what we mean by this. We will see classification of discontinuities. There are different types of discontinuities. First one is called removable. Second one is called as a jump. Third one is called infinite. Let us understand the definition. What you mean by discontinuities. Removable. Limit exists, but f of a is not equal to limit of x approaches a f of x. That is the previous case, right? We have seen. So limit exists, but the f of a, first point. The second, you get the limit, and then third, you should see f of a should be equal to L. So if these two are, if two exist and then this doesn't hold, then such a discontinuity is called as removable discontinuity. Next, jump. In the jump, say that f of a exists and then the LHL is not equal to RHL. That means limit doesn't exist. If limit does not exist, such a discontinuity is called as jump. Okay, this is called as jump. And the third one is infinite. That means if this limit value, so for example, say f of a exists, then this limit L value is say equal to infinity, plus or minus infinity. Then this kind of discontinuity is called as infinite discontinuity. We'll see with the help of a graph, we'll understand. So here is your different types of discontinuities. Removable means what? There is a hole here, right? At some x equal to a, for example, say for some x equal to a, there is a discontinuity at this point. So such a thing is called as removable. Jump means, see, from when I approach from left hand side, this point and this point are same, that is say x equal to a, some point. The LHL value is this point. This is your LHL, right? F of x is given here. This is f of x for this. This is your right hand limit. I am approaching from this side, approaching from this side. They are not equal because this will give different value and this will give different value. Already given. No? This is some different value here and different value here. So left hand limit is not equal to right hand limit. So this is called a jump. You can see in the graph there is a jump. Then the third one is the asymptote, the vertical asymptote, that is infinite. This green color line you are seeing, it's the, for some functions when it is y equal to infinity, y equal to infinity or minus infinity. This is for example plus infinity. So for x equal to say at a, the y is infinite. So this is also called as vertical asymptote. Okay, this is a infinite kind of discontinuity. Hope you got it. Next, so now till now you understood continuity at a point. Now we will see continuity in the on the intervals, both type of intervals. It is open interval as well as closed intervals. So first, see what is that you are saying? See, at a point is different. So such say that there is a curve like this. There is an interval now. This is A. And let us say this is my B. Now when I say continuity, I am checking for this entire region. I am checking the curve not at a point. From this point till this point means this. I am checking this entire line between A and B is continuous or not. So how to check it? First, let us understand terminology. Continuous from right at A. Okay, continuous from right at A means from here in this direction. So that means how will you write? This is nothing but your right hand limit, right? X approaches A plus. That means my X is greater than A. F of X is equal to F of A. This is the condition. Similarly, continuous from left at A. Left at A means, okay, from A minus. So let's say b here in this. Okay. If I take it b, it will be easy for you to understand. So b, left of b means from this side. So limit of x approaches b minus means f of x should be equal to f of b. Okay. Now continuous on interval. Open interval a comma b. Continuous at every point in a comma b. The open interval a comma b means what? A less than x less than b. That's what they are saying. So on every point for x in this a to b, okay, so it's an open interval, so we will exclude a and b. Then continuous on open and closed interval a comma b is continuous on a comma b. So all these three conditions should satisfy now. Continuous on this, continuous on this, and continuous on this. What they say, from this point also it should be continuous. This point also is included, and then this entire this is also included. That is closed intervals. We will take some simple examples to understand. Find intervals of continuity f of x equal to x plus 2 by x square minus 1. Now you have to find out the intervals in which this curve is continuous. Now if you observe here, when you solved the domain, finding the domains of a function, so you found out in which intervals they are working. That means they are not undefined. So that is the same thing here. So how to solve? So what should be the denominator? If I put x equal to 1 or minus 1, okay, this will fail. So x square minus 1 should not be equal to 0, right? Not be equal to 0. That means say it is not equal to 0. So for all what values, x equal to plus or minus 1, if I put, it will be 0. Other than this, other than these two values, minus 1 and plus 1, you should be working. How will you write? Okay, starting from minus infinity and then till minus 1, not included, because minus 1 is here, till say minus 0.9999, something like that. Then union, so minus excluding minus 1, then from minus 1 point say 001 to 1, because 0 is included, 0 1, and then 1 should not be also again included. Okay. So then from there till 1 to infinity, that is 2 to 1 point something to infinity. So that means what is that I'm writing here? This is basically means minus infinity to infinity except minus 1 and plus 1. This is what I have written. Any values other than this. So that is, this curve is continuous on this, in these intervals. One more example. Let us say f of x is equal to square root of 9 minus x square. So for this to be defined, should not get a complex number here. That means the square root of negative number is a complex number. So what, for what value of x this is valid? So 9 minus x square, okay, should be greater than or equal to 0. That implies x is equal to plus or minus 3. So any value other than this is valid only in this interval, closed interval. If I put minus 3, it will be 0. So square root of 0. If I put plus 3, it is square root of 0. If I put any big number, okay, or smaller than minus 3 or greater than plus 3, so I don't, it will not work. So the answer is this. This is the interval where it is continuous. This curve is continuous. Next, composite function theorem. The composite functions already are seen, f of g of x, something like that. When you apply it to limit, and how will you find it? At the continuity. So if f of x is continuous at L, let's say f of x is continuous at L, and limit of x approaches a g of x equal to L, then so limit of x approaches a f of g of x is equal to f of limit of x approaches a g of x. This is nothing but what? This is already given as L. This approaches the value L. So this means f of L. What you can write. So f of L, the L is x of x approaches a g of x. Is L is given. So f of g of x means substitute g of x inside the function f. A simple example we'll take. The limit x approaches sine 3x. Okay. So let us say g of x was given as 3x, and then f of x is equal to sine function. So now how will you write? You can write it as limit of x approaches sine g of x. This is limit of x approaches sine 3x. So as limit, what is this? Limit x approaches 0, g of x equal to 0 means I will get it as 0. So this becomes what? Limit of x approaches 0 sine 0. This is equal to 0. This is example for limit of composite function. Next. So it is helpful to understand that continuity of a trigonometric function. See, all the trigonometric functions sin x, cos x, tan x, cot, secant x, cosec x are continuous at their domains. So all these functions are continuous. All trigonometric functions are continuous in their domains. Please, this is a very important point. Now, there is something called as intermediate value theorem. Again, we will learn in further chapters this concept when I explain mean value theorem. So what it says, let us say the same example, continuous interval. So this is my curve. Let us say this is my point A, B. If f is continuous, they already given that this is my f of x. Okay? This is my f of x, my x. If f of x is continuous on this curve between A, B, okay, from this point included, open interval, close interval. From A to B, this curve is continuous. There is no discontinuity. Okay. Then z lies between f of a, f of b. This point, no, point is f of a. This is function value at b, that is f of b. Then there exists a point lies between z lies between f of a and f of b. Okay. Then there exists c. There exists a value c that belongs to a comma b, the open interval. That means somewhere say here, it's c. There exists a point c between a and b such that f of c is equal to z. That means this point is equal to f of c. This is the intermediate value theorem. Let's take an example. Show that f of x equal to x cube minus x minus 2 as the root in 1 comma 2. Now let us take f of x equal to what is x cube minus x minus 2. Then they are given a comma b interval is equal to 1 comma 2. So what the intermediate value says, there exists a point between a and b, that is c value, such that there is f of c is equal to z. So what it means, f of 1 is equal to minus 2 less than 0. F of 2 is equal to 4, that is greater than 0. So there exists c that belongs to 1 comma 2 such that f of c is equal to 0. You can write it like this, because it is less than 0 and this is greater than 0. Okay, f of 2 is greater than 0, it's less than 0. So there is one point where f of c will be 0. So that means what? this x cube minus x minus 2 is equal to 0. Okay, for some value of x, that is nothing but c. So how will you find that? So this is your beginning of your numerical methods. Using numerical methods, you find the root. If it was simple equation, just you can solve it using the finding the roots. Similarly, f of x equal to cos x minus x as a root in 0, 1. So f of 0 is equal to, that is cos 0 is 1, is greater than 0. Similarly, f of 1 is equal to cos of 1 minus 1, that is something equal to 0. Minus 0.4597, which is less than s. So that means what? f of f is continuous because the trigonometric function, it's continuous. Then IVT guarantees, that intermediate value theorem guarantees, there exists c that belongs to 0, 1 with f of c such that f of c is equal to 0. That means what? Cos x minus x is equal to 0 for some value of x. That is what we are saying, this c. Okay. How to find that value? That is your, again, applying your numerical methods. It is easily ready, you can easily find using this equation, that's fine. Otherwise, we usually go from finding the roots using numerical methods. So that is the basic concept about continuity. We'll solve few more problems in the next video. Okay. So thank you for watching. Please like, subscribe.